Okay, now we move to example 2. An alpha particle charged positive 2 electron is sent at high speed towards a gold nucleus charged with positive 79 electron. What is the electrical force acting on the alpha particle when it's 2 times 10 negative 4 meter from the gold nucleus? So, it's too easy. So in this chapter, you only have one equation. F is equal to K Q1 Q2 over R squared. Now in this question, you have to find what is the electrical force. So you still have to find force. This is the R, this is the charge number 1, charge number 2. F is equal to 9 times 10 power 9. Q1 is 2 electron. Q2 is 79 electron, and both are positive, over R 2 times 10 negative 14 squared. Okay, so first you have to calculate 2 electron. If you want to calculate outside, then you substitute inside here also can. Okay, so how to calculate 2 electron? 2 times 1.9 times negative 19, 1.69 I think. Charge of electron is 1.6. Sorry, 1.6. 1.6 times 10 negative 19. Okay, so what's the answer? Then you substitute into here. 79 electrons, 79 times 1.6 times negative 19. So what's the answer? Substitute here. After you find the answer, substitute here, then you can calculate for force. Okay? Okay. 2 electron means this is the charge of electron, which is this one in our second slide. Yeah. This one. 1 electron is equal to 1.6 times 10 negative 19 coulomb. So this is the value for 1 electron. If they said for 2 electrons, so 2 times the value. If 79 electron means the 79 of electron. Positive means it's a proton. Okay, so just find the force. Okay, now we move to example 3. An electron is released a short distance above the surface of the Earth. The second electron is directly below. It exerts an electrostatic force on the first electron, just great enough to cancel the gravitational force. How far? How far means the R, the distance. Below the first electron is the second. Okay, I draw for you. An electron is released a short distance above the surface of the Earth. So, surface of the Earth. An electron is released a short distance above the surface of the Earth. So, electron. An electron. A second electron is directly below it. Just below it exerts an electrostatic force on the first electrons, just great enough to cancel the gravitational force on it. So, here is the second electron, just great enough to cancel the force, the gravitational force on it. Okay, how far below the first? Okay, here is the R. You have to find the R. Now, what equation you want to use? Of course, F is equal to K Q1 Q2 over R squared, right? Okay, so now you have to find R. First thing first, you know the K. What is Q1? Q1 is the electron, which is 1.6 times 10 negative 19. This is the Q1. Q2 also same, an electron, so same value with this. R, you don't know. F. What is F? Okay, in the question itself, it stated that a second electron directly below it exerts an electrostatic force on the first electron, just great enough to cancel the gravitational force. Okay, in previous chapter, laws of motion, what is the gravitational force? Very good. Gravitational force is the weight. Weight is equal to mg. Weight is one of the forces, right? So force will be weight is equal to k q1 q2 over r squared. Weight you can expand with mg is equal to k q1 q2 over r squared. Okay, in this case, what unknown you have? Okay, now K you know, Q1, Q2, electron 1, electron 2, R you don't know. M, what is M? Mass of the, now we talk about electron, so mass of the electron. Mass of the electron is the constant, which is, you can find from this slide. Mass of the electron is 9.11 times 10 negative 31. So you can substitute here. Mass of the electron 9.11 times 10 negative 31. Why mass of electron? Mass of electron because the object now is the electron. If the object now is the proton, if the charge now is the proton, so you have to use mass of the proton. It depends on the question given. G, gravity is equal to 9.81. Okay, is equal to this side. 9 times 10 9 times 10 negative 19 squared over r squared. So find r. R is equal to how much? Alright, should be in meter because everything already in SI units. Okay, clear? This question is about 1, 2, 3, 4, 5 marks minimum. Okay, now we move to another example. Example 4. Example 4 I think is quite easy for you. For this chapter is quite easy because you just use F is equal to K Q1 Q2 over R squared. So example 4. Two identical conducting spheres are placed with their centers 0.3 meter apart. So here will be the R. One is given a charge of this one, so here will be your Q1. Another charge of this one, so here will be your Q2. Q1 is proton, Q2 is electron. Find the electrostatic force, so you have to find F. You just use F is equal to K Q1 Q2 over R squared. So electrostatic force, you have to find this one, how much? K is 9 times 10 to the power 9. This one is constant. Q1 is 12 times 10 negative 19. This is the value. Q2 is 18 times 10 negative 9. There's no negative here because all of these are modulus. So all the charges will be modulus even though you are given negative charge. R is equal to 0.3. And don't forget the square. Okay, after you calculate, you will get F, force. So F, you get the answer. The unit is Newton. Okay, now we will jump into this example 5, the last example, which is the most important example, and minimum marks for this question is 10 marks. Okay, first, calculate the magnitude and direction of the Coulomb force on the three charges shown in figure. Actually, for the complicated one, actually direction you have to calculate the, if it's slanted, should be calculate the angle. That one should be the direction, right? Magnitude, how to find magnitude is just to use the Coulomb's law, which is F is equal to KQ1 Q2 over R squared. But in this case, okay, your syllabus is Introduction to Physics, which is a very simple physics. So in this case, the direction we just explain that it's attract or repel only. You just take like this, okay? Okay, so in this case, I show you how to do it. First, I draw back the question. 6 microcoulomb, 1.5 microcoulomb, negative 2 microcoulomb. So here will be 3 centimeter. here will be 2 centimeter. Okay, now you have to find magnitude and direction. So this is, you have to find force, which is F is equal to K Q1 Q2 over R squared. Direction, you just put repel or attract. Okay. Okay, so in the first case, you have now how many force you have here. You have charge number 1, number 2, and number 3. So how many force you have here? Okay, very good. For the first one, you have F12, which is the force between charge number 1 and charge number 2. So you just state F12. If you want to state F21 also can. Okay. What is the other force? Between 2 and 3. So F2, 3. Okay, the other force is between F12 is force number 1, F23 is force number 2, and the other one is between charge number 1 and number 3, which is F13. So each of the forces, you have to calculate the value of force or the magnitude of the forces. So the first one, F12, 1, 2. So you use KQ1, Q2 over R squared. So K is 9 times 10 over 9. Q1 is 6 micro. Please put micro inside your calculator. Micro means times 10 negative 6 if you don't have, if you don't want to press the micro symbol. Okay. Charge number 2 is 1.5 micro. Both of these are positive, so just put positive. Even though it's negative, you just put positive because it's modulus, over 3 centimeter, right? The distance between two charges. So 3 centimeter convert to meter is divided with 100. So 1, 2, 0.03 squared. So what's the answer? Unit Newton. Okay, this is the magnitude of the forces. Magnitude. How about direction? Okay, as we stated before, we just use the simple direction. No need to use tangent theta y over x, that's all, because it's a straight line. Okay, so between F12, is it repel or attract? Okay, now how do you know it's a repel or attract? Look at the charges. The first one charge is positive, the second charge is positive also. So positive is a like charges, so like charges will be repel. So put a bracket, repel. So here will be your direction. Right? Now settle for the first force. Now we move to the second force, which is F23. So F23 here is force number 1 is 1.5 micro. The third one will be negative 2 microcoulomb. So negative 2, you just put 2, non-negative, inside the calculation because all the modulus. So K is 9 times 10 over 9. Q1 is 1.5 micro. Micro you should state it here because micro is the value, which is times 10 to the power of negative 6. And charge number 3 is 2 micro over 2 centimeter is 0.02 squared. So what's the answer? Newton. Put a bracket. Charge number 2 and number 3, positive and negative. Unlike charges, right? One is positive because positive value here, negative, negative, so it's attract. Okay. So the last one force is F13 between charge number 1 and number 3. So you just take it. Here is Coulomb constant. K. Q1 is 6 micro. 1 and 3, right? So between 1 and 3 charge. So 2 micro should be negative. Originally negative, but because of the modulus sign, so it's become positive. over, okay, what's the distance between charge number 1 until number 3 is 5 centimeter, right? 5 centimeter convert to meter will be 0.05. So what's the answer? Newton, put a bracket. Charge number 1 is positive, charge number 3 is negative, so unlike charges, it will attract. So that's how you do these questions. It's minimum 10 marks. Alright, so that's all we learn in this chapter, electric force. This is the important part, that you know how to find the magnitude of force, which is you have to use this equation. Okay, and please remember Q1, Q2 always in modulus, so always positive. R, please remember you have to square. After you find the value of F, that will be the magnitude or the value of force, and the direction, you just put repel or attract. Okay, if it's complicated one, you have to use tangent theta equal to y over x. You have to find the for the force you will have x and y, but for in this chapter I will not teach the complicated ones because you are from IT students, so you just learn how to know the basic things. Okay, that's all for this chapter. Thank you very much.